Hi class, today we are on Saxon Math, Book 4, Lesson 92, and we are going to be talking about classifying quadrilaterals. Now, I have spoken to you before about these first four, and I put them in the order that I always write them down for you. I like to write them in this order because quadrilateral, parallelogram, rectangle, and square goes from the most general type of four-sided shape down to the most specific type of four-sided shape. Excuse me. So the first thing we have is a quadrilateral, and a quadrilateral is anything that has four sides and it's a closed polygon, a closed shape. So I might have a quadrilateral that looks like this, but it's still a quadrilateral, or a quadrilateral could look like that, or a quadrilateral could look like that. All of these are closed shapes with four sides, and that's the only requirement for something to be called a quadrilateral. The next, slightly more specific rule or name for a type of quadrilateral is a parallelogram. In a parallelogram, opposite sides of the shape must be parallel, and a parallelogram also has four sides. So these were all quadrilaterals. Two of them, let me grab an eraser here. Two of them are also parallelograms. This one is not. Those opposite sides were not parallel, but here they are. This is parallel to this, and this is parallel to this, and then here, parallel, 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 parallel. So these are both parallelograms, and they're both quadrilaterals. We're going to get slightly more specific and talk about a rectangle. A rectangle is a parallelogram, so it has four sides, it has opposite sides that are parallel, and a rectangle has 90-degree angles. So this is a rectangle, this is not. Another example of a rectangle might be that one. It's still a quadrilateral. It has four sides. It's still a parallelogram. Opposite sides are parallel. But now it also has 90-degree angles, so we call it a rectangle. A rectangle is the most specific name for this shape because this shape follows all the rules that it needs to follow in order to be a rectangle. Finally, the most specific type of quadrilateral is a square. In order to be a square, your polygon has to follow the most rules. It has to have four sides. So all squares are quadrilaterals. It has to have opposite sides that are parallel. So all squares are parallelograms. It has to have 90-degree angles. So all squares are rectangles. And it has to have four equal or congruent side lengths. So this is not a rectangle. This one's almost a rectangle. I think I made it just slightly too long. If I do that, I'm sorry, a square. It is a rectangle. Now it's also a square because my side lengths are the same. All right, we're going to throw two more words in there, and I placed them where they are on purpose because trapezoids are a special kind of quadrilateral, but they are not parallelograms, and they're not rectangles, and they're not squares. A trapezoid has one set of parallel sides. So this is the most typical trapezoid that you will see. because it has one set of parallel sides, but the other set are not parallel. So that's one example of a trapezoid. That other picture that I had before, that's also a trapezoid because I have one set of parallel sides and one set that are not parallel. So trapezoid is another specific type of quadrilateral where one set of its sides are parallel. And then a rhombus is a type of parallelogram where all four of its sides are congruent. So a rhombus is not a square because it does not follow the rules of being a square. A square has to have 90-degree angles. A rhombus is like a square that got pushed and it kind of fell over a little bit. So it's a parallelogram, but if all four sides are the same length, then we also call it a rhombus. Kind of a funny word, rhombus. All right, I have a couple examples for you that go along with this information, starting with which of these quadrilaterals is not a parallelogram. So they're going to give you F, G, H, and I. Which of these is not a parallelogram? Remember, a parallelogram has to have two sets of parallel sides. H does not, it only has one set of parallel sides. So H is not a parallelogram. All right, the next example says, this one you're going to have to do with me. Draw two parallel line segments of different lengths. So start out with that. If you have a whiteboard or a piece of paper, draw two parallel line segments that are different lengths. Then form a quadrilateral by drawing two line segments that connect the end points. So your end points are where your line starts and stops. So you connect them there, connect them there. What type of quadrilateral did you make? Remember, one set of parallel lines, it's called a trapezoid. Kind of a funny word, trapezoid. Trapezoid, one set of parallel lines has a trapezoid. Okay, the next one, I have to draw a bunch of shapes. It's another multiple choice. Says, which of the following quadrilaterals has sides that are not parallel or perpendicular? So we have A, we have B, we have C, and we have D. Okay, so it says, which of the following quadrilaterals has sides that are not parallel or perpendicular? You know what? I think I drew this one a little bit off because that looks, there we go. We'll talk about it. In your book, it might look a little better than how I drew it. So A, do we have parallel sides? Yes, both sets are parallel. Do we have perpendicular sides? Yes, this little square corner here shows you that those two sides are perpendicular to each other. B, do we have parallel sides? Yes, two sets. Do we have perpendicular sides? No, but the question is looking for which shape doesn't have parallel or perpendicular, so this one still fits. C, do we have parallel sides? We're not supposed to. My drawing, you're kind of like, without a ruler, I can't tell exactly, but it's not supposed to have parallel sides. Do we have perpendicular angles? None of these little square corners. So that's not a perpendicular intersecting line. D, do we have parallel sides? Yes, we have one set. Do we have perpendicular sides? Yes, right there, and then again up there that I didn't draw the square corner for, but this one shows that they are perpendicular and parallel. So C, I would encourage you to look in your book and see the drawing of C. I want you to notice that it doesn't show any of the square corners. So that's how you know that it's not perpendicular. Your book will mark with this notation right here if they want you to know that the shape has a 90-degree angle or a right angle, another word for 90 degrees. All right, that problem is on page 586 if you want to look at how the book drew the pictures. They did better than me. All right, our next example says describe the angles in each of the quadrilaterals in example 3. I shouldn't have erased those. Okay, so the first one was A, and it had that little square corner, but we can also see, man, I think I did even worse at drawing it this time. We can see that's meant to be a square. So it actually has 4 right angles. Problem B was a parallelogram here. And we want to describe the angles. So looking at these two, what do we call that cute little type of angle? Those two are acute. And what about these big fat angles here? Those are obtuse. We have 2 acute angles and 2 obtuse angles. C, let's see if I can draw it better this time around. It still kind of looks like a trapezoid to me, but it's not meant to be. Okay, so in C here, let's take it one angle at a time. This one here, does that look like it is more or less than 90 degrees? It looks slightly more, so this would be an obtuse angle. I'm going to turn it. Feel free to do that when you're looking at these shapes if it helps you kind of compare maybe to the corner of your page, which should be a 90-degree angle. This is also going to be slightly bigger than a 90-degree angle, so that's also an obtuse angle. This one here, that looks slightly smaller than a 90-degree angle, so we'd call that one acute. And then this one is definitely an acute little angle. And finally, we had shape D, where this one was marked as a right angle. In the book, this one's also marked as a right angle. So we have 2 right angles. We have one acute, tiny little angle, and one big, fat, obtuse angle over there. All right, so you guys have an activity. It is in your book on page 587. It says, look around the room for quadrilaterals. Find examples of at least 3 different types of quadrilaterals illustrated in the beginning of the lesson. So you're looking for 3 of those. 3 quadrilaterals, 3 trapezoids, 3 parallelograms. I'm sorry, not 3 of each. Any 3 is what you're looking for. So maybe you find 1 quadrilateral, 1 rhombus, and 1 rectangle. Or maybe you find a square, a rectangle, and a trapezoid. You're looking for 3 examples of the 6 words that we have up there. When you find those, show them to your homeschooling parent and say, look, Mom, I found a trapezoid, or look, Mom, I found a rhombus. Do you remember what a rhombus is from school? Rhombus is one of those words that you use a lot in elementary school, middle school, and high school, but as an adult, you're kind of like, rhombus? So test them, see if they remember. There is another activity which you will need a mirror for. So if you are able to test lines of symmetry with a mirror, if you have like a little handheld mirror at home, you can try that activity on page 587 as well. All right, your lesson practice has a lot of pictures and a lot of drawing. So I'm going to have you do that on your own. Please make sure a homeschool parent checks your lesson practice to make sure that you understand these different shapes and their attributes, which means kind of what the side lengths look like, what the angles look like, and hopefully you can draw them better than me. I hope you have a wonderful day. Don't forget to do your written practice, which begins on page 588, and I will see you again soon.